Here are solutions to homework set number 5 for ECE 111. The first problem is kind of beating to death the two basic equations for circuits. For circuits, V equals I times R. And the second one is power is volts times amps. And there's other variations of this. That's basically the two. Given two parameters, I can find the rest. If I know volts and amps, volts divided by amps gives you resistance. Volts times amps gives you power. If we know voltage and resistance, volts divided by R gives you amps. Volts times amps is power, and so on. One way this is often remembered is a little triangle. So I've got volts, amps, resistance. So volts is amps times resistance. Voltage over current is resistance. Voltage over resistance is current. Yeah, basically beat these two equations to death. So that's problem number 1. Problem 2 is kind of like a Sudoku puzzle. So this uses conservation of voltage. Around any closed path, the voltages have to add to 0. So find a path where there's one unknown, like right here. This tells me that minus C plus 52 plus 109 equals 0. I'm back where I started. Or another way to do it, if I pick a point, like right here, if I go this way, then the voltage is 161 volts. If I go this way, I've got to get the same answer, so C has to be 161. Now I can solve for B. If I go this way, I get 220. If I go this way, I also have to get 220, which tells me that this is 59 volts. I can now solve for A. This way is 152. This is 152. And so on for all the rest. When you're done, you should wind up with these voltages. Problem 3, conservation of current. Conservation of current says if I have 100 milliamps flowing in, at this point, I've got to have 100 going out. So 31 goes right, the remainder goes up. This has to be 69 milliamps. And also right here, I've got 69 going out, I have to have 69 going in. At any point, current has to add to 0. For B, 69 coming in, I've got to have 69 coming out. 44 goes right, which means I've got 25 milliamps going down. 44 amps going in, I got to have 44 going out. 25 goes right, so this is 19 milliamps. 25 is 6 plus 19. 6 has to be 6. Notice that if there's no split, the current in these two have to be the same. That's called series, two elements in series. And so on. When you're all said and done, this should be your answer. Conservation of current. Next one, resistors in series and parallel. So this is where HP calculators are really, really nice. You can solve with other calculators. HPs work better. My opinion is they're worth 10 points on a test, and I don't think that's an exaggeration. For example, here, I need to figure out which resistors are series, which ones are in parallel. So here, these two are in series. That means the current through the 660 also goes through 640. In series, they add. So the HP, I do 660, enter, 640, and HPs use the stack. And it's kind of like German. In German, you say, Father will the ball throw. Verb goes at the end. You got to set it up, then do the operation. I've got these two numbers, and what happens with them? I add. So this is 1300. In parallel, it's the sum of the inverses. So it's 1 over R1 plus 1 over R2. That's the net resistance in parallel. So let's take this resistance, invert it, take 610, invert it, add the inverse, invert. So all this together is 415 ohms. Now add 120. I could hit enter, but HPs are kind of nice. It knows if I did an operation, it knows this number is something important. When I hit 120, it automatically pushes it on the stack. So if I type in 120, notice the 415 just got pushed. I can now add. These are in parallel. So take the inverse, 730, inverse, add inverse, 308. So the total is 308.79. Again, highly recommend you get an HP calculator, get used to it. This is a free app on your cell phone called Free42. Some instructors don't like cell phones on tests. I'm trying to get them to accept them, because the chip shortage, they're kind of expensive now. But HP is basically a company of electrical engineers, and oddly enough, they build really good calculators for electrical engineering. Highly recommend it. Don't learn how to use it on a test. They do have a learning curve. They're a little bit different using RPN notation, but once you get used to it, they're really, really fast. So that's problem 1, 308 ohms. Problem 2 is verify in Circuit Lab. So what I can do is build a circuit, apply a 1 volt test, and find the current. It says the current is 3.28 milliamps from V equals IR. I know the voltage, 1 volt. I know the current, 3.28 milliamps. Solve for R. I get the same answer, 308, with a little bit of rounding. Problem 3, and I'm miscounting my solutions, but problem 3. Find the total resistance. Again, this is series and parallel, so these two in series gives you 500, enter, 50, add, or you can just do this in your head. No, it's not that hard. In parallel, again, in parallel, it's 1 over the sum of the inverses. So let's take this inverse, 400, take its inverse, add the inverses, invert it. So all this together is 231 ohms. And I'm going to save that as store 02. I'm going to use that later. Now all this can be replaced with essentially 231 ohms. This is in series with 40. In 40, you add. In parallel with 300. In parallel, you take the inverse, 300, inverse, add, inverse. So all this together is 142 ohms. And I'm going to use that number later, so I'm going to store it. Plus 30. Total resistance is 172 ohms. That's what I see looking in. I can check that in Circuit Lab. Build the circuit, apply test voltage, find the current, and it says the current is 5.78 milliamps from V equals IR. Voltage over resistance is voltage over current is resistance. It's 170. Well, it's supposed to be 172.5 ohms. There's a little bit of rounding going on. Same answer. Okay, so those two numbers I kind of saved. Now find V1, V2, V3 by voltage division. What voltage division does is if I know the voltage of V2, I can find V3. It's what I'm measuring. So V3 is what I'm measuring, 500 ohms, over the total, 500 plus 50. That times V2. And kind of where that comes from, if I take V2 divided by 550, I get the current. Current times resistance is voltage, so take that answer times 500, or rearrange slightly. It's this percentage of V2. But I don't know V2. If I knew V1, I could find V2, but I don't know V1. If I knew V0, I could find V1. I do know V0, so V0 is 10 volts. So I can find V1. It's going to be this resistance looking right, so all this together looks like 142 ohms. So let's do recall 02. Why save that? Okay, what did I do wrong? Oh, maybe a new circuit. So 550, inverse, 400, inverse, add, inverse. All this is 231 ohms. Plus 40. In parallel with 300, take the inverse, 300, inverse, add, inverse. All this together is 142 ohms. Store a 1, plus 30. 172 ohms. Okay, so let's take this resistance, 142, that's why I saved it. Voltage division, and here I'm going to do a trick. I'm going to do enter, enter. That creates 2 copies of 142. Now add 30 to it. That's my denominator, R1 plus R2. And I hit enter twice because that made 2 copies, and lo and behold, there's the numerator. Take the numerator divided by denominator times 10 volts. This is 8.26 volts. Now, let's find the voltage at V2. And again, I'm going to show off how nice the HP calculators are. Erase all this. I'm going to take what I'm measuring, recall O2, that's why I saved it. Enter, enter, plus 40. There's your R1 plus R2. There's the R2. Take the ratio, and lo and behold, there's the previous answer. That's what the stacks are nice. They record the old ones. Multiply. 7.04 volts. I now have 500. Enter, enter, 50 plus, slash, times 6.4 volts. So that's the voltages by voltage division. And note the HP calculators are really, really nice for this, especially when you get to complex numbers. Highly recommend. Get an HP calculator. Get it, get to know it. It's worth 10 points on tests. In Circuit Lab, I can check my answers. Build in Circuit Lab, I get the same answers. So that's homework set number 5 for ECE 111. Again, this isn't really a MATLAB assignment. We'll get to MATLAB next week when we start getting 2 equations, 2 unknowns. But for 1 equation, 1 unknown, you can just use a calculator. Homework number 5.